Good morning. Good morning, ladies and gentlemen. We are delighted to have you all here today. My name is Miss Ati Rahma, and I am honored to be your master of ceremony alongside my partner.
I am Amalia Rafiq, and first and foremost, we would like to express our sincere gratitude for the opportunity to gather in this virtual space for the second International Conference of Multidisciplinary Studies in 2023. We are truly grateful for your presence and participation in this event. Allow us to extend our warmest greetings to the distinguished individuals who are joining us today. We would like to welcome the Excellency Dr. Alimuddin Rizal MM, the Chairman of the Board of Yayasan Pendidikan dan Penerbit Mahasiswa Indonesia, and all the management members, supervisor involved with YPPMI,
Dr. Edwina LST Master of Engineering, Rector of Stikubang University Semarang, along with the Vice Rector, Deans, and Director of the Stikubang University Semarang. Dr. Kristiawan Nugroho MCom as the Committee Chairman of the second ICMS 2023.
And also we would like to welcome the keynote speaker of this international conference. Our first speaker is Professor Omar Farooq, PhD, from Alika Muslim University, India. And our second speaker is Professor Andi Liu from Hub University, Malaysia.
And as moderator today, we have Ms. Ajeng Aquina, SAMM from the Stikubang University, Semarang. We also extend our welcome to all participants joining us today, including a lecturer from Stikubang University, Semarang, attendees of this online conference, all students of Unisbang, and viewers of Unisbang TV from across the globe.
Now let us officially commence the second International Conference of Multidisciplinary Studies, Smart Technology and Creative Economy Transformation to support post-pandemic development, hosted by University Semarang, Stikubang Semarang Unisbank in 2023. As we gather here virtually via Zoom and live streaming on the Unisbank TV channel, we are presented with an exceptional opportunity to explore innovative ideas and approaches that can shape our post-pandemic life.
As we commence the first part of our program, I kindly request everyone to stand as we pay tribute to our beloved country with the singing of the Indonesian national anthem. Following that, we will also be honored to hear Mass from Stikubang University, Semarang. Mars from Universitas Tikubang, Semarang.
Universitas Tikubang Semarang, Chandra di muka putra putri bangsa, pusat pendidikan vokasi akademik dan profesional berbasis teknologi informasi. Lawan sesat negeri mulia, itulah semboyan kita. Universitas Tikubang Semarang, tanamkan kepribadian bangsa. Cerdas berwibawa, cakap bersahaja, siap berbakti pada negara. Universitas Tikubang Semarang, Chandra di muka putra putri bangsa, pusat pendidikan vokasi akademik dan profesional berbasis teknologi informasi. Lawan sesat negeri mulia, itulah semboyan kita. Universitas Tikubang Semarang, tanamkan kepribadian bangsa. Cerdas berwibawa, cakap bersahaja, siap berbakti pada negara.
Thank you, ladies and gentlemen. The next agenda is conference chairperson report, which will be delivered by Dr. Kristiawan Nugroho, MCom. For Dr. Kristiawan Nugroho, MCom, time is yours.
Okay, thank you, Miss Leah. Praise the Lord. Assalamualaikum warahmatullahi wabarakatuh. Good morning, all authors, participants, and honorable guests. The distinguished rector of Universitas Tikubang, Dr. Edi Winarno, Master of Engineering. Dear all the audience of great researchers, dear honorable guests, and all representatives from universities and other institutions, the distinguished keynote speakers, and dear authors and participants for today's webinar conference. I'm pleased to welcome you to the webinar on international conference to discuss the scope, computer science and engineering, social science, management, and humanities. I'm highly honored to take this opportunity on behalf of the committee and organizer to welcome all of you today to the second international conference of multidisciplinary study, ICMS. Second ICMS was held after the COVID-19 pandemic was over. So this event is expected to make scientific contribution to research development. Last year, first ICMS was carried out well. Now, with the new topic, smart technology and creative economy transformation to support post-pandemic development, there are 59 papers accepted out of 61 submitted papers from 5 different countries, including India, Pakistan, Japan, Malaysia, and Indonesia. It is also my honor today to have two great persons who have agreed to be keynote speakers for this webinar. The distinguished two persons are follows. One, Professor Umar Faruk, PhD from Department of Electronic Engineering, St. College of Engineering and Technology, Aligarh Muslim University, India. Two, Professor Andi Liu from Hub University, Malaysia. Therefore, I would like to thank all the organizers, supporters, and organizing committee members of Second International Conference of Multidisciplinary Studies, who have made this conference happen. I believe that without their support and hard work, the second ICMS would not have come through. I believe that by participating in this webinar, together, let us accelerate the exchange of ideas, scaling up of good practice, and mix collaboration together. We do hope that in this webinar, second ICMS is also going to be a great success like the one last year. And we request for you to support this, make this event make a memorable and successful one. Thank you for your participation and enjoy the series of webinar ICMS event. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Arika Saputra has joined the meeting. MTI has
Thank
joined
you.
the meeting.
The
LVN
honorable audience, so we now proceed the next segment of our program. This is the space
06
on
has
audiovisual
joined the
opening,
meeting. The
which will
host
be referred by the
host
rector of
press
Stikbang
CMD plus to open
University
pop-up.
Semarang.
Putri DEWIA Unisbank has joined the meeting. Leila Kodriou has
The
left the
Excellency
meeting.
Dr.
Ardas
Edwin Narno,
Supriyanto has
ST Master
joined the
of
meeting.
Engineering.
24210028378 ANDY and URCHYNUGRAHA has left the meeting.
Bismillahirrahmanirrahim.
Putri has left the meeting.
Assalamualaikum warahmatullahi wabarakatuh.
Has joined the meeting.
Good morning, ladies and gentlemen.
Tanpari has joined the meeting.
Alhamdulillah, Alamin.
Has left the
This
meeting.
is for all of us.
Has joined
Om
the meeting.
Swastiastu,
Ashila
Namo
has
Buddhaya,
left the meeting.
Salam
Dacia
Kebajikan.
Putri has joined the
The
meeting.
Honorable, the Chairman of Yayasan Pendidikan Penerbit Mahasiswa Indonesia, by IPMI, Mr. Dr. Almudin Rizal MM, the Honorable, all members of the management and supervisors of YPBMI, the Honorable
Press Shift plus Command plus E.
and also we would like to say special thanks and welcome to distinguished speaker Prof. Omar Farouk PhD from Al-Azhar University India, distinguished speaker Prof. Andi Liu from Health University Malaysia, and the moderator Mrs. Ajeng Aquinia SCMM from Stikbang University Semarang, Indonesia, and the honorable all of lecturers, researchers, students, or the presenters that will convey the ideas in this conference, and all of the participants who attend to this online international conference today. Hopefully, we are always keeping health and safety from our God, Allah Subhanahu wa Ta'ala. Ladies and gentlemen, as we know, the second international conference of multidisciplinary studies, ICMS 2023, that had today is a level up from the national conference of multidisciplinary studies, and we say which has been held that always had by Stikbang University Semarang. The first conference was held last year, and the conference that had today take the title Smart Technology and Creative Economy Transformation to Support Post-Pandemic Development. On behalf of Stikbang University Indonesia, I would like to welcome you to the second international conference of multidisciplinary studies, ICMS 2023. In this time, I would like to say a special thanks to all of the speakers that will talk about smart technology and creative economy transformation after post-pandemic. Distinguished participants, ladies and gentlemen, I think this conference is very, very important and very, very interesting for us because it will talk
about everything,
Santoso
especially about
has
the
joined
solution in
meeting.
technology
Luciana
and economy after
Priyangarani
pandemic.
has joined the meeting. Risky Ramadani Putro Utomo has left the meeting. Andrea Costume Award
Ladies and gentlemen,
the meeting.
I wish this conference will be nice experience for all
Has joined the
participants.
meeting.
Hopefully, all of you will enjoy the conference, enjoy the virtual meeting here, and we hope that all finding, all innovation in this conference would be realized and would be given.
Close.
And by saying Bismillahirrahmanirrahim, the second international conference on multidisciplinary studies ICMS 2023 is officially open. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Has
warahmatullahi
left the
wabarakatuh.
meeting.
Thank you, sir. Well, ladies and gentlemen, before we go to the next agenda, let's take a moment to capture this special occasion by having a group photo together. Because although we are in virtual meeting, we can still create a sense of togetherness by taking a photo together. So all attendees are requested to turn on your camera, please, and let's take a picture together. And I would like to counting down in 3, 2, 1, and we will take a photo. Okay, are you ready, everyone?
Okay, ladies and gentlemen, ready everyone? Let's capture this wonderful memory of the seminary opening. 3, 2, 1, take picture. Okay. And the audience can all put your thumbs and give your best smile. Okay, thank you. Amalia.
Thank you, Ms. Ati. So, well, ladies and gentlemen, the next series of events is for the opening of the second ICMS. Okay, ladies and gentlemen, that was the series of opening, and we go to the next agenda. It is the main agenda is seminar session, which will be directed by the moderator. So the moderator is Ms. Ajeng Aquinia, SAMM from Sikupang University Semarang. She is an expert in marketing management and social media marketing, especially on TikTok. So for Ms. Ajeng Aquinia, please welcome. And without any further ado, time is yours.
Okay, thank you so much for the warm welcome coming from our MCs, Miss Atik and also Miss Amalia. Good morning, everyone, and welcome to the second ICMS in 2023. I'm Ajeng Aquinia, and it is a great pleasure for me to be here as the moderator in the second ICMS in 2023. Well, first of all, I'd like to greet the honorable guests and also all the participants who already joined online, both on Zoom and also live streaming from Unsbang TV channel. Ladies and gentlemen, as we know that the smart technology with its remarkable capabilities has become an integral part of our lives. From AI to the Internet of Things has revolutionized the way we work and also communicate and even solve the problems. The pandemic take part of faster adoption of smart technology, and we can also witness the power of digital connectivity in keeping businesses afloat and societies connected during physical restrictions. Earlier, we heard that the government already announced that the pandemic is over. Therefore, we're going to discuss more about the role of smart technology and creative economic transformation to support post-pandemic development from a different point of view and perspective that coming from our speakers. Before we begin, I'd like to inform you that due to urgent duty, Professor Chandra and also Professor Paul Chan, who were scheduled before, will be unable to attend this conference. So we will have two sessions in this conference. First, we have Professor Omar Farouk, and second, we have Professor Andilio. Well, ladies and gentlemen, let's begin with the first session, yeah? I'd like to read a brief introduction about our first speaker here. Is Professor Omar Farouk, that's coming from Department of Electronics Engineering, Aligarh Muslim University, India. And he's graduated PhD and also postdoctoral from Loughborough University in United Kingdom. His focus and research interests are in the features extraction for speech recognition application. And also, Professor Omar Farouk received so many awards and from international conference. Today, Professor Omar Farouk will share an insights about the automatic sleep apnea detection by using EEG signals. Before the presentations begin, let me tell you how this conference will run. So the first speaker will be presented for the material for about 45 minutes, and after that, following by the discussions with the audience for about 15 minutes. And for the audience who have a questions, you can write down below in the chat, or you can using raise hand button. And later, the committee will open up the mic as well. So ladies and gentlemen, without further ado, allow me to welcome our first speaker, Professor Omar Farouk. Professor, the time is yours.
Thank you very much.
Yeah, you're welcome, sir.
Good morning, everyone, and Assalamu alaikum, all the participants and the organizers. To start with, I would like to first of all thank Director of Citibank University for giving me the opportunity to address this audience and taking this initiative to organize the second conference, ICMS, which is focusing on the smart technologies and creative economic transformation, focusing on the post-pandemic era. I would also like to thank the organizers of this particular conference who has taken a lot of pain in organizing this and having a number of papers being received. And I hope that it will be a success and there will be a fruitful result coming out of this. I specifically would like to thank Dr. Esteban. He was actually instrumental in roping me to this particular conference, and I am honored that I got this opportunity to address this audience. With this, I would like to start my presentation. Essentially speaking, I am from India. You can see this slide, and over here you can find Aligarh, which is located in the northern part of India. So I am essentially over here. somewhere the weather is pretty bad. Currently, the schools have been closed because of heavy rain. This is my university, which is the Aligarh Muslim University, the main entrance. One of those antique building, which is more than 100-year-old, the Stretchy Hall, and the Victoria Gate, which was named after the Queen Victoria. And this is our broad view of the engineering college, where my electronics engineering department is situated. So this is from where I'm addressing you all, and probably participants are from different parts of the world, not only located in Indonesia, plus it will be Malaysia, India, Pakistan, and probably in different countries as well. This, I would like to just give you the overview, what I would be talking about. First of all, the basic motivation, the post-pandemic, that was the COVID-19 pandemic, what were the different health issues that we faced and what were the different challenges. Then the mental health, I'll talk about the mental health. And because mental health, essentially, we have got brain, which is controlling our mind. So I'll talk about brain and how do we capture signals from brain. And then we will dive into this sleep and how we can actually detect one of those problems of sleep, which is sleep apnea. And then we will have the conclusion and question answer sessions. So if we see the basic challenges that we faced during the lockdown, if we start from here, then there were everywhere uncertainty present. The postponement of different things, the cancellation, the schools and offices were closed. People were actually restricted to their home, and there were no social interaction. So this was a challenging time, and this was a stressful time to all of us. And not only these things, but we were also having fear and anxiety that we may get infected. Our near and dear ones were actually getting infected, and many of our close known relatives and friends, they actually left or departed this world because of this. So these all things actually created a lot of stress, and the problem was actually faced by not only adults, but also in children also, which caused mental health issues. And that was the basic reason why we started about this mental health. The stress factor that we actually got was many of those who were working on daily wages, they lost their livelihood. So the income was a problem. Many companies, they actually reduced the workforces, and therefore, or the pay scales were reduced. So because of all those things, the income actually reduced, and it was stressful for many of us during that time. Then, as I told you, that the death or our near and dear ones, they got infected and they got hospitalized. So that was a stressful moment, again, putting pressure on the brain itself. Not only physical, but mental stress was also present during this time. This gave rise to many of those behavioral issues. Specifically in small children, we do encounter those changes till now, and we are trying to cater those things. The fear of the disease, the sense of isolation. This was one of the most important things that we actually encountered, that there was no socialization, but thanks to the virtual network that was established during that time, that we could actually interact with people through different social media, and we could actually not only communicate in the terms of audio, but visual as well. So that was helpful in a bit, but anyway, this was a stressful period. So again, a lot of stress, mental stress was there. change in the working environment. As far as the university environment is concerned, we were actually using ICT enabled teaching, most of us. But then this was totally transformed, where now there were no students in front of us. We were sitting in front of a screen where we could see students, some of those students. And because different students, they do come from different places. Some of those students were living in villages where the network connectivity was not there. So those sort of issues and challenges we faced, as well as the students faced. So this was again a stressful moment because of the change on the working environment. Because of these reasons, we had various health issues, and health issues can be actually divided into 4 different categories. The physical health. The physical health means how well we are physically, we are not having any disease. Then the social health, which actually gives us the idea that how we interact with people, how we are having social relationship within the society, how do we participate in the society. So social health became an issue during this particular period. The physical health was a big challenge because the movement was restricted. The emotional health was also a problem because we didn't have social interaction. Because of that, we became more irritable. We actually reacted a lot on simple issues. Gives us the power to cope up with our daily stress that we are having. We were down in mental health as well. And because the mental health or the brain controls the entire body, therefore, if there is problem we face in mental health, it will be reflected not only in mental health, but physical, social, as well as emotional health. So this became a root cause that would actually affect all the other health that we are having. Now, coming to the COVID-19, the post-pandemic era that we were talking about, and this conference actually focuses on that. If we see that the COVID had some important symptoms, which were actually fever, cough, breathing difficulty, a respiratory issue was there. And because of respiratory issue, the sleeping problem cropped up. Because of those cough and fever, the sleep disorder actually came into picture, and it rose during that particular period during the pandemic. The stress and anxiety, if a person is stressed, then usually he will have a problem of insomnia or less sleep or disturbed sleep. So everything was affecting the sleeping pattern. Some of those people who were having now different shift, different routines, so that also affected the sleeping pattern. And above all, some of those medications that we took during the COVID-19, that also created drowsiness, and that also created fatigue in persons. So all these things combined together gave a problem which is known as sleep apnea. We'll talk about the sleep apnea, what it is, but this is a sort of disease which is related to breathing problem, and it is about 1 billion people worldwide are diagnosed with it. And many of those people are not able to access these facilities to go for the diagnosis. In the recent studies that was actually published in 2023 of COVID-19 patients and those who were the control group, this is what the summary of that paper was. it was related to the sleeping pattern of those who were COVID positive, tested positive, 519 subjects, and the COVID negative subjects who were 18,266. So the study was made and they were actually asked questions and they responded to this question. So the first is the excessive daytime sleepiness. Those who were negative, they responded that there was an increase of 10.8%, but those who were tested positive with COVID, 22.8% said that they were having excessive daytime sleepiness. So that means actually the night sleep was not proper and they were having more daytime sleeping on. They were having more fatigue. That is the second thing. 28% who were COVID positive, they said that they were having more fatigue. 66.1% they said no change, and 5.6% said that there was a decrease. So, but this number is pretty small as compared to 28% those who were tested positive. Similarly, the excessive quantity of sleep, that is more than 9 hours. So you can see that it was about 10.8% in the COVID positive patients, and excessive tendency to fall asleep because of the infection, it was 27%. So this actually showed that there was, as in general, sleep disorder because of the prevalence of COVID-19 pandemic. And we need to actually look at this particular issue because these issues are creeping on post-pandemic as well. And we need to look for some smart technology to diagnose this problem and how to actually have some remedy with simple diagnosis. So this was the basic motivation of this, that this common disorder, which is now more common because of the COVID-19, we need to look into that and develop a technique by which we can detect sleep apnea. So basically, how do we define sleep? It is slightly different as compared to a person who is not conscious. So it is not simply the absence of wakefulness or perception or suppression of sensorial process. It is different from the unconscious state in which the mind remains alert and there are many activities that are going on when we are sleeping. And sleep is a reversible process. So this is important that when we sleep, there are many secretion, hormonal secretion that do take place, and we do find its utility we'll see in subsequent slides. This is the average sleep time that we do encounter in different animals. We can see varying from a very short duration, roughly about 3 hours to 20 hours of sleep. So we as a human are roughly 8 hours a day. That means 1/3 of our life we are actually sleeping. This actually helps in restoration and healing. That's why when you sleep, that a person who is in fever, you will find that, or he is having some viral infection, he will sleep a lot because automatically the body or the brain signals that you should take rest so that the healing and the restoration process is accelerated. Otherwise, more energy will be burned when we are not sleeping or engaged in some activity. So this is helpful in restoration and healing process, survival of the various species. For example, the predators are there on move. So when those animals actually sleep, they are hiding at some places and therefore they are not being killed by the other animals. it is essential for hormonal balance and immune system function. It helps in learning also. This is very important, that it has been found that the information that we intake during the daytime, that is actually stored and reinforced in our brain as a long-term memory, some of those events, and that takes place when we are actually sleeping. Sleep deprivation is again an important issue that we can address separately. I'll quickly go through these things. Now, coming to the sleep apnea problem, as indicated over here, the normal breathing passage is shown where the air can go through the nostrils and pass on through the trachea and goes to the lung. But usually what happens sometimes, because a person is heavy in weight, bulky, or he is having some problem, there is a obstruction occurring at this particular point. This may be because of the less activity of the muscles. The muscles actually collapse and they may reduce the air passage, which will limit the flow of air and which will limit the supply of oxygen to the body and ultimately to the brain, which becomes very important. Apnea occurs when this passage is totally closed. When it is totally closed, there is no supply of air, the pressure builds up, and then it will try to open up, because of which we may have snoring also coming. But because the brain doesn't receive oxygen, it will actually send a signal that there is some breathing issues, and unconsciously when we are sleeping, we will turn aside, flip or toss on the bed, so that automatically the posture changes and we actually have this opening of the passage. So it may occur, this closure of passage may occur several times. And when this closure is more than 10 seconds, then we say that this is the problem of apnea. It is more prevalent in male adults as compared to female. So hypopnea is actually the closure which is occurring, but it is a partial closure. It is not a full closure. And apnea is a full closure that occurs. So we do classify this apnea hypopnea index based upon the number of times that closure or partial closure occurs over an hour duration. So mild, moderate, and severe. Severe means that it will be occurring more than 30 times per hour. And this 30 times means that of more than 10-second duration. The symptoms that we do find is loud snoring. This may be one of the symptoms, but those who snore will always have sleep apnea. That's not correct. Plus, the person will be having a daytime sleepiness. So he will be drowsy or feeling sleepy during the daytime because of the apnea problem. And he may wake up with headache or sore throat. He may have memory problems. He may frequently wake up during the sleep. So these may be some of those symptoms which we do encounter. This is another sleep scale which is used actually to assess how much sleepiness is there and whether the person is suffering from some sleep disorder or not. This is an subjective measure in which these questions, 8 questions are given to subject, and he actually ranked them between 0 to 3. And then based upon that score, the total score, the assessment will be carried out by the experts. Now, because the sleep that we are having is controlled by the brain itself. So I'll have a brief overview of brain and brain imaging process, because I will be talking about detecting sleep problem or specifically sleep apnea using the electroencephalogram, that is the EEG, which is actually the recording from the brain. So I will have a brief overview of this brain structure, which is the consists of 4 different lobes. The frontal lobe, which actually governs the personality of a person, the emotional status, and it is active during the problem solving event. The parietal lobe, which is centrally located, and this helps in cognition and developing a relationship and mathematical abilities, the spatial relationship, or the non-verbal memories that we are having. The occipital lobe, which is at the back of our head, which is actually responsible for vision, color, shape detection, movement detection. So it is mainly where all the optic nerves actually terminate. Whatever we are seeing will have the interpretation done in the occipital lobe. The temporal lobe is on the left and right side, just above the ears that we are having, and it is taking care of the speech and auditory processing. So the language that we learn, the understanding of the language, and the long-term memory, all those processing is done in this particular region. These have been actually experimentally determined that which area is activated. To know how these or when these areas are activated, we need to do some sort of imaging technique, that when we do a specific task, which portion of the brain is activated. So various imaging technique, one of them is the electroencephalogram, as shown over here, that we do have a cap in which these electrodes are actually connected, and these electrodes capture the electrical activity that is going in the brain. Although these electrodes are on the surface, on the skull, but these are of high grade, so they pick up those electrical activities going beneath that particular region, and the signal which is then collected is known as electroencephalogram. Usually we have got a number of channels for that. We'll go into a bit more details about EEG specifically. Electrocardiography is the intercranial recording in which surgery is required and the electrodes are implanted beneath the skull. So this can be seen over here, because now this implant is beneath the skull in the brain itself. So the signal that we get is much much better in quality as compared to EEG. But then the procedure is complex and it is not usually followed in most of those applications. That is magnetoencephalography is there. That is magnetic field. Using a high magnetic field, we can see that how the movement of ions are there in the brain and which portion of the brain is active. So this is one imaging technique. Other is the functional magnetic resonance imaging. These are the images, 2-dimensional images or 3-dimensional images that we actually obtain from here, and then we cut slices and try to analyze the entire picture. Another technique is using the near-infrared signal, which is in the range of 700 to 900 nanometers, and these infrared signals are actually irradiated on the skull, and based upon the absorption spectrum that we get, the hemoglobin and the will absorb some of those specific frequencies. So based on those absorption, we try to detect where the oxygen is present more, where the oxygen is present less. So based upon the oxygen concentration, we will know that this area of the brain is more active, because when the brain area is active, it will consume energy. That means it will require more oxygen, and hence we'll get that particular idea that activity for a specific task is located in a specific region. Now, this is a comparison, and this is important. Why? Because when we talk about smart technologies and we talk about something which is again important, but I am not going to talk about that, that is brain-computer interface. So that area which uses brain signal, all those applications want that the device that we are making should be portable. So if we look at the brain activity and how we can record those things with a portable device so that we can use it for smart applications, EEG is important over here because it gives us high temporal resolution. That means it will have faster processing and faster information retrieval from the brain itself. The spatial resolution is not very high. This is about 10 millimeter or roughly 1 centimeter. But now we may have high density electrodes also coming, which may improve upon these resolution. MEG is using the magnetic field, but the basic problem is it is not portable. The advantage is that it is not invasive. Both of them are non-invasive technique. So this can be used in smart applications that we are having. ECOG is invasive. That's the basic drawback of this is it is invasive. It may be portable, and it uses electrical signal, very high temporal resolution, high spatial resolution. All these things are there, but this is invasive. So specifically for some of those BCI applications which is being carried out, or the Neuralink project which is going on, all these sort of things, in those sort of projects, we are trying to have invasive techniques being used so that we can have better understanding and better quality signal being achieved. Functional magnetic resonance imaging or functional NIRS, all these are actually non-invasive technique, but the NIRS is a portable device which is now becoming popular and is having now competition with EEG analysis, which is being used for BCI application or prosthetic applications. So I will go very quickly through this history. EEG was actually discovered by Richard Carlton in 1875, way back. And that was while he was experimenting with rabbits and monkeys, he found that there was some electrical activity in the brain. And later in 1924, the German psychiatrist Hans Berger, he actually discovered and actually coined the term electroencephalogram and performed the first recording in 1929. So this was the recording, the rough recording, which can be seen over here, not a very good resolution at that time. And he found that for different tasks, these waveforms actually change. So that was his original contribution. And now we can use EEG for information gathering, that means from the brain itself, diagnosis, malfunctioning, pathology or abnormality detection, monitoring, periodic monitoring can be done, or therapy or neurological disorder detection can be done, and evaluation can also be done, objective analysis. So these are various applications which we can find. Now I'll go into a bit more detail about the EEG recording. This is a standard recording mechanism which is known as 10-20 system of recording. So the electrodes that holes over here. You can see the holes. So here these electrodes can be placed, and these are stretchable caps, so it can fit to the head size and go to the specific location which is desired. The number of electrodes may vary. Usually it may be as small as 2 electrodes or 3 electrodes that we may have, and it may go up to 512 electrodes placed all over the scalp. The sampling frequency is usually low, which is 256 usual cases, but nowadays we do find that there are instruments coming at higher sampling frequencies, because some of the recent findings are that there are high frequency information also present, which earlier we discarded because of very small magnitude. But now, because of better signal processing, we can extract those information, and we can actually have the analysis based on those high frequency oscillations. Grounding is usually done by placing an electrode which is in the earlobe. That is the most common grounding reference point. The voltage level is in microvolts, as you can see over here. That this is the plot with which we get number of channels are shown over here. Now, if we go into the detail of a specific waveform, we will find that it has got various frequency components, and some of those frequency components are important. The delta wave, which is very low frequency, up to 4 hertz, and it is the slowest wave, lowest frequency with highest amplitude, and this actually occurs when we are in deep sleep stage. That means if we try to analyze the EEG signal and we analyze this particular band, we will be able to get information whether the person is in deep sleep or he is drowsy. So this is very useful when we try to do a sleep scoring or sleep assessment, that whether the person had a sound sleep or not. It is not important that you were in bed for 8 hours, but it is important that how sound you slept and what were the different sleep stages that you entered. So that is more important. So this band is useful in determining deep sleep stage. Theta band, 4 to 8 hertz. Usually you will find that there may be slight difference in the lower and the higher frequencies mentioned in different places, but it's not much. Somewhere it may be 8 hertz, somewhere 7 hertz or 7.5 hertz, but usually this is the range that is there. And this frequency occurs when we are sleeping or we are feeling drowsy. So if the lecture is very boring, then if we try to measure the EEG signal, then we will find a lot of activity in this band because the person is feeling drowsy and he is not enjoying that talk. So this is one way of measurement of attention that a person has. Then the alpha band is there when you are wakeful and eye closed, relaxed. Beta band, when you are thinking, you are doing some sort of problem solving in your brain, you are concentrating on an issue. So higher frequencies, they do creep up when we are doing actively some processing in the brain. Various problems that we have in EEG is that we cannot have a very good localization in EEG. Spatial resolution is poor, that we have talked about. Plus, it is affected by many of those artifacts because the signal is in microvolt. If I am measuring the EEG of a person and he is blinking the eye, then that will create an artifact. If he swallows something, that will create a artifact. Or the person is sweating and there is sweat in the skull, then also that will be artifact. If you take different types of food, then the EEG activity will change. If you are in stress, then the EEG activity will change. So there are many issues that we need to take up when we are collecting the EEG data for a specific task. But what it has been found is that many of those frequency components or the parameters of the EEG are actually task dependent, task related. So that has been found, and they produce some reproducible results. This is also good in neurofeedback system, where we try to treat people who are having drug abuses and anxiety and depression. So how those drugs that are being monitored or medicines that are given to a person is actually changing the brain state of that particular person can be actually monitored. Another very important application is brain-computer interface, which is now coming up in a big way, where you later on may not be typing on your computer, but you think whatever you want to type and it will automatically be written over there. So you think that I should switch on the air conditioner and it is automatically switched on. So those sort of processing is BCI application. Now, diagnosis that we do for the sleep apnea is collecting the PSG signal, polysomnography signal. A person is actually admitted to a hospital. He has to sleep there for a night, and these are the attachments that are there. SpO2 is there. You monitor the SpO2, monitor the brain activity, monitor the ECG signal, monitor the expansion of the chest. This is a belt that is there. The muscle activity, the snoring activity, the EMG signal is actually recorded. So there is variety of signal, about 32 different channels are there, which are actually a recording is done for the case of PSG signal. I will be just concentrating on the electroencephalogram, how we will be using electroencephalogram to determine the sleep apnea problem. The other signals I will just not take into account. So coming to the actual problem now, a bit more technical now. To perform the sleep apnea detection, we need to have a database which is setting a gold standard. That means we should have a data where recording, PSG recording was done, and where the marking has been done by the expert that the person is having apnea when the apnea is occurring, and when the apnea is absent, when the breathing is normal. So that standard marking is usually done in some of those databases. So we have used a freely available database which has got 2-channel EEG, as shown over here, that these are the 2 channels, C3, C4. These are the channels that are there, and these are the reference electrodes placed on the ear. So simple 2-channel recording, because other channels, 32 channels are there. Other channels will be ECG, EEG, and other signals will be recorded. So simple, very small electrodes are used, number of electrodes are used. And that's why we have chosen this problem, because we are now currently trying to have a FPGA or embedded system implementation of this simulated algorithm that we will be talking about. We have not yet finished, and we have not yet published on this, but we are still on the way. I'll show you some of those partial results. So if we want to detect the sleep apnea, that is the EEG signal, we have to have some data acquisition. Then we'll do the pre-processing and perform the feature extraction, and then finally the classification. So these are the stages that we will be doing. Because the data is already available to us, so we'll start from the signal processing aspect. The data which we have used is actually from the Dublin University sleep apnea database. It is from the St. Vincent Hospital, from where it has been actually acquired. and it consists of 25 different subject recording. The sampling frequency was 128 hertz, and these were the number of frames which were having apnea. Details when it started, when it ended, all these are given in the detailed database, and the link is given over here at the bottom also. So if somebody wants to download this database, this is freely available, and he can do some research work based upon his interest. Now, what we have done is that we took the EEG signal, and the EEG signal, the two channels that we had, C3, as I told you, that C3 electrode, and A2 was the reference of the ground one, C4 and A1. So we did the time domain averaging. This is usually done to have an average picture, and this is what has been reported in earlier literature also. So we tried to replicate the same thing so that we can compare our results with their result. So it was a time domain averaging, because both these channels are sampled at the same rate. So we take the samples and average them. And the average signal was pre-processed. Pre-processing is important and essential in most of those applications. We'll see in the subsequent slides. Then we performed band pass filtering. Different bands that we have seen, delta, theta, alpha, sigma, beta, gamma, all these bands are there. So we actually did band pass filtering to extract the signal in specific bands. And then we performed the feature extraction in each of these subbands. So feature extraction, features are actually something which is important and characteristic of a specific class. So we had actually a two-class problem, the normal and the apnea. So we tried to identify features which were good to separate these two things. But because the data is pretty large, huge data, and we do work on higher dimensions, not 1 or 2 dimension or 3 dimension, higher dimension. So visualization and understanding which feature will be giving better result visually is not possible. So we had to go for some sort of mechanism which is known as ranking of those features. Once the features are extracted, they are cascaded together, all those features, and we rank those features, that which features are good and which features are not so good for the classification into these two classes, apnea and non-apnea. So coming to the pre-processing, why do we require pre-processing? There are artifacts, as I told you, that there may be some muscle activity, the ECG activity, or we may have artifacts which are non-physiological from outside line interference. When we do any recording, 50 hertz or 60 hertz line interference will be there. So that is to be actually taken into consideration. So pre-processed data, which was actually filtered, and then we use a band pass filter to separate out delta, theta, alpha, sigma, and beta bands. These are the filter characteristics that we have used over here. Some of those filters frequency response is shown over here. Now, after filtering, we do a feature extraction. Feature extraction means that we will take as I told you, that the marking is done for 10 seconds. So 10-second epoch is taken. We analyze in different subbands, and then we extract features. Then we shift non-overlapping window, and we keep on doing this till we reach the end of the recording. So this is how we extract features. And because if there are number of channels in the case of EEG, then we may have a number of channels like this, or if we are, in this case, we are having number of bands, first, second, third, different bands are there, and we have extracted features. So we'll try to extract features from all of those bands. Some of those features that we have used is shown over here. This is simple energy calculation. This is mean absolute deviation is calculated. That is the deviation from the mean value. And then kurtosis is calculated, which gives the idea of how much peakiness is there in the distribution. Skewness is calculated. That is the third order central movement, which actually tries to see whether the distribution that we are getting is symmetric or it is non-symmetric. So if it is skewed left side or right side, that skewness actually gives us a positive and the negative value. And we have calculated entropy. Along with this, we have calculated other features also on all those bands. So resulting into very large number of features, 5 subbands. So we can multiply it by 5. That many numbers of features were there. Excuse me. Then we used a classification technique in which we actually divided into 2 classes, training and test classes, and we performed the 5-fold cross-validation. Ranking was done because now we have got large number of features. We try to rank those features and then take top few of those features. Now, feature ranking can be done by various methods. What we have tried is the first method, that is filter type selection method, in which we try to see which feature is more relevant and which is less relevant for the classification. So this is actually not related to the training algorithm, independent of the classifier that we are having. We will use this filter type feature selection. Wrapper type feature selection is a technique in which we try to start with small number of features, 1 feature, let us say, and then we keep on adding the features and see that how the model performance improves. Or the other way around, that we may start with all the features and start removing 1 by 1 features and see that how the performance is changing and detect an optimum point where the performance is best and the features are small in number as well. And then the last one, which is very computationally intensive, is embedded type feature selection, in which we try to have a joint optimization in which features along with the learning or the training model that we are having, the classifier that we are having, they are jointly optimized. So a specific feature may work good for one model and that same feature may not work for another model. So this type of optimization is carried out. So we carried out the first optimization technique. This is just to show you visually how the high rank feature, good features are and how the bad features are. You can see that blue one is the apnea feature and the magenta one is the non-apnea feature. These 2 features are not having a lot of overlap. That means this will be good for classification. This is a high rank feature. This will be giving us better result. While this is a low rank feature, you can see that there is a lot of overlap between these 2. So this is not a good feature. We try to evaluate the accuracy, the sensitivity, and the specificity of the features that we have selected using the classifier. This is the evaluation matrix, which actually tries to give us the true positive, true negative, false positive, and false negative values. And from here, we calculated these 3 parameters. We tried to do some sort of comparison as well. This is a comparative performance in which what we have proposed and 2 of the results that were published in 19, we published in 20, and then we had subsequently published in some more journals also. So the first one was actually using a racial model, and they used the same subject, same actually database, and same window size. Every calculation parameters were the same, but features were different. So the sensitivity that we have got for the case of 003 subject is 97% as compared to what were reported in the earlier two cases. The proposed technique have better specificity and better accuracy, higher accuracy, much higher we were getting with the proposed set of features that we are having on feature selection. However, specifically, if we see for the subject ID 020, here the performance that we have proposed was not very good. These features were performing better for this subject, and in all the cases, our performance was not good as compared to what was proposed by energy ratio. A slightly different approach, which was similar to subband, but they have calculated the ratio of the energy. But if we calculate the average performance, then the average performance based upon our algorithm was superior as compared to what they have done. And we have used an ensemble classifier. We tried to do some more experiment and added some more features and then performed the ranking, and then used random forest and decision tree. And here the random forest and decision tree actually improved the performance better as compared to what we were getting previously in the case of decision tree. Random forest was getting better result. And further, we have done something using neural networks, ANN, which actually improved the result from the random forest further, one step further. How much time should I take now?
You still have 10 minutes left, sir.
10 minutes left. Okay.
Yeah.
Fine. Thank you.
Yeah.
So implementation, what we have actually done was that we did this experiment on MATLAB, doing the simulation, taking the database, and then generating the results. But when we actually want to do the implementation, which is on the FPGA, then we have to look at many different issues. That means we should look at the power consumption. We should look at the hardware that we will be using. So some features that we extract may require a lot of computation. Maybe those features are good, but they require, memory requirement is huge, computation power is more, and hence the power requirement will be more, battery will be draining. So our basic objective was that we would like to have a low power design. So we decided that we will identify some features which give us less complexity in terms of hardware requirement and should be fast in computation. So this was the proposed implementation technique that we have done. The EEG recording was present. We will do the filtering and band decomposition. So this was done, and then the output was given to the feature extractor. This was the software simulation process. This was carried out on MATLAB. We extracted the features, ranked those features, got those top ranking features, and these top ranking features, we have introduced something which is mobility extra over here, which was giving us better result as compared to the previous one and required less computation as well. So we used two classifiers, ANN and SVM, and trained them and detected whether the apnea was there or not. So this was the simulation that we carried out in MATLAB, and then based upon this training process, the SVM will generate a function which will have certain variables, those specific values specifier that we get for SVM, or the weights and the biases that we get from the trained neural network will be actually used in the hardware. So once the training was done using the MATLAB, we got the result. Then we tried to do the implementation in the hardware block and use the trained model in the hardware block, see the results that we have got, and then calculate the power consumed and the resource utilization, and also compare these results from what we got in MATLAB, because we would like that these results should not be very much different as compared to what we are getting in MATLAB. There may be a slight amount of difference because in MATLAB, when we do computation, we may be using precision, double precision, maybe we will be using floating point numbers with precision of 32 or 64 bits. Here, it may not be possible in this particular case when we are doing hardware realization. So there will be certain approximations that will be made, and hence it is possible that we may get some difference in the results. So this was the block diagram which was implemented in hardware to extract the energy. We input the signal, and because the sampling frequency was 128 and we are having a 10-second window, so we will have 1280 samples inside the buffer. So this will be flushed out and we will calculate the square, and then we will have the summation of the square of all the 1280 samples, and then it will be output as a feature. So this is one feature that we can calculate, one of the block diagram that I have shown over here. This is another implementation of mobility, which we found that this has been used mainly in electromyographic signal, EMG, the muscle signals. So we try to use for the EEG signal also, and this requires less computation, and this is a good high rank feature. So we have implemented this, which is the variance of the samples that we are having, x minus xi. So it is the differentiation actually that equivalent time domain representation, it extracts the frequency domain information. So here the buffer is used, and we do have a square, simple square integral. Sum of the square is done over here, and then the calculation of those entire features, multiplication and division. These actually multipliers and dividers, they do, these operations are more complex and difficult to implement, requiring a lot of resources. So these things were actually implemented, and we got some of those utilization reports from the Xilinx Vivado. This is just the prelim results that I am showing you. We have not yet published it. So unpublished result, still we are in a process of refining these things. So the number of DSP and the number of FFT and IO pins, the details over here, utilization, we can see. The important point that we want to show you over here is that how much power, on-chip power, that has been assessed on Adtrix 7 FPGA. It is roughly total on-chip power is 137 milliwatt, and dynamic power only 20 milliwatt is there, static power 117, junction temperature, not a lot of heating going up. And these results which are being generated, they show that this is with high level of confidence. That means it should be there, good. And we have implemented the ANN in this particular case. further details probably will be coming up when we publish the paper in detail. I have not deliberately shown some of those details over here because we have not yet published. Now, at the end, what I would like to conclude is that based on this result that we have got, we could see that sleep apnea can be detected with high degree of accuracy. But now what we were trying to do is that to develop a small prototype using the smart technology as the theme of this particular conference is, and then whether it can be used as a portable device, easy to use for mass production, so that it is available at every place. We don't require a sleep lab, because sleep labs are rarely available in various places. In district, usually you will find one place, not one place, and small places you may not find sleep lab at all. So if this device is available, we can do a simple analysis of that data easily at any place. And this will be helpful in diagnosing a problem which we actually don't put a lot of weightage, sleep apnea, because this may lead to problem which is heart attack problem. I don't know whether you are aware about Indian Bollywood or not, but a very renowned musician, Bappi Lahiri, Bappi usually known as, he actually recently died because of this problem, because he was having a sleep apnea. He was very obese, and while sleeping, you don't know that that occurs. It actually chokes, and person have heart attack as well. So this may be a fatal thing. Apart from this, what we have done in future, what we could do is we can have a sleep assessment also. Sleep stage, in which stage of sleep we are having. There are various stages. I have not talked about that. Stage 1, 2, 3, and then REM sleep. So we should, a normal person should have specific amount at each stage to have a proper sleep. So we can assess that, and then we can score that what is the sleep quality. Sometimes you sleep and then you wake up and say that I don't feel fresh. That is happening. And sometimes we say that, okay, you slept for a few hours and you woke up very fresh. So there is an app also available. If you go to Play Store, probably it will be there, Better Sleep. So that app is a paid app, of course, maybe 7 days it is free. So you can try and you can switch it on while you go to sleep, and it will do an audio recording. It will record when you were snoring, what was the duration of that, and what was the quality of your sleep, and it can set an alarm. See, it's very important that when you are, there is a sleep cycle. Once you complete a cycle, if you wake up, then you will be fresh. If you wake up in between the sleep cycle, when you are in deep sleep, somebody wakes you up, you feel very annoyed and you don't feel fresh. So that sort of thing, that app actually sets the alarm accordingly when your sleep cycle is completing. So when you wake up fresh, just maybe when the sleep cycle is over, not when you are specifically in a very deep sleep and the alarm goes up and you feel very annoyed. So sleep quality, this is a big sort of thing which young researchers and young people can take up this problem and work upon this. So with this, these are some of those references. The last two references, more recent references are there, which is on the obstructive sleep apnea detection, machine learning, and nowadays people have switched to deep learning as well. So that is also coming up. Thank you very much for your attention and for the time that you have given.
Yes.
It is open to questions now.
Yeah, thank you very much, Professor Omar Farouk. Well, actually, to be honest, I'm really excited with this topic because it's related to myself. when I saw the symptoms on your slide.
Okay.
Because I feel so exhausted when I wake up in the morning. There's something in
Okay.
trouble. And this is going to lead the first questions that I want to ask you, Professor. Is it any different quality of sleep based on age? Because lately when we are in the 20s, we never snore or something like that. We feel so fresh when we wake up. But then around 30s, it's become so exhausted when we wake up and feel so tired even after sleep for 8 hours, something like that.
Yes.
Is there any difference quality?
Yes. There is a difference because with age, the sleep duration actually changes. A newborn, you will find that he is sleeping for about maybe 16, 17, 18 hours or so, always sleeping. But as the age progresses, the sleep duration actually reduces. Also, when the age progresses, the muscle stiffness actually goes down. So when you sleep, also the body relaxes, and we become a bit more obese, and the muscle is not that stiff. So what happens is automatically those muscles collapse, and it tries to partially block the air pipe, and we do end up with sometimes snoring and these sort of problems. So 8 hours is, as I told you, is not very important. It is the quality which is important. I may not be able to reach to that deep sleep stage. I may go to stage 1 and 2, and then I started snoring, and because of snoring and obstruction, I need to change my posture, and therefore I will change my posture and I come back to stage 1 again. Instead of going to stage 3, I come back to stage 1. So
Yes,
that creates a problem that we do find that I have been in bed for 8 hours, I am not fresh. Reason being that I didn't have the quality sleep. So if we can access that quality, then you feel tired because you are having a problem of sleep deprivation. And sleep can it can be because of stress also, because you are growing older, you are getting more and more responsible.
Right.
You get more and more responsibilities, administrative responsibilities, and all those things. So you're a bit stressed, and your brain, although you think that you are in bed, but your brain thinks that, okay, tomorrow I have to do this, tomorrow I have to do this. These are the meetings lined up, and I have to address to this audience at this gathering. These are the classes. So that goes in your brain, subconscious mind, and you may not be able to sleep properly.
I see.
Not
in
good quality.
Because it's happening nowadays after the pandemic, the schedule was very tight. Then we sleep like we feel never sleep. So when we wake up, we feel exhausted. And how we get the quality of sleep itself when we are in the 30s or 40s, like in the productive age, something like that?
Now people there are alternative ways of things coming up. Maybe a bit of exercise is better. Maybe a bit of meditation is better.
Okay, exercise and meditation is also helpful.
Meditation, yes. So because we need to relax ourselves, we need to make ourselves free of stress, because subconsciously we are tied up with the work or the office work, even when we go home.
Oh,
so
okay.
That we need to tackle actually.
Okay, Professor, thank you. Well, Professor, we'll actually have several questions here, but due to a limited time, we're going to hear 2 questions that are coming in the chat. So I'm going to read the first question. It's coming from Miss Lisa Desiarimbi, that I want to ask about the EEG could be the main basic for sleep disorder diagnosis or not. Or before give a diagnosis about sleep disorder, the patients must combine it with the counseling or psychological tests before that.
Okay, EEG is not the only way for classification of or detection of sleep apnea. The experts actually, they look at all the channels, 32 channels, and a lot of work has been done using ECG signal also. electrocardiogram, because the recording 32 channels it has got ECG also. So ECG is used, and there are a lot of work in which ECG is found to change when there is apnea problem. And people have detected this with accuracy ranging in 90% accuracy. So this has been reported. People have done work using only the oxygen saturation level, SpO2 level, and muscles activity, EMG. So various options people have tried. SpO2 is very simple and easy to monitor, easy to handle. The amount of data is very small, but it may not be giving us a very high reliability. Therefore, the brain, because brain is actually controlling everything. The heart rate is controlled by the brain, is giving us the signal. So all those change in the signal which is occurring because of the breathing pattern, brain is controlling that. That is the source. So if you analyze the source, it becomes the best. But the problem is it is difficult because the signal strength is very small. So it requires a bit of signal processing, detailed processing, to analyze those signals and extract the information.
Okay. Thank you, Professor, for the first question here. And for the second question, Professor, we got from Mr. Ari Juliar. So asking about, is it to get a feature fetch at any given moment or using time series data? I mean, if we want to get the feature fetch, is there any specific moments or using time series data?
No, it is not a specific moment, because when we are trying to analyze data, the data is usually in real-time application. It is streaming, it is coming. So you don't know when the event will be occurring. What we try to do is that we take a 10-second window, 10-second signal, and then we analyze each and every second and extract features. So those features will be different for apnea, and it will be different for non-apnea cases.
Okay.
So we need to identify those things. For example, I want to differentiate between what should I say, apple and a potato. So if I want to differentiate between them, I will say that, okay, I will have the color as a feature. Apple will be usually red, or it is green, and the potato will be brown in color. So that color is a feature that will distinguish between them. Maybe the weight is not a good feature to distinguish. So similarly over here, I would actually try to look into the signal characteristic to start with, see how they are different in time domain, how they are different in frequency domain, or how they are different statistically by plotting their PDF, and then analyze them and see which features will be good to differentiate between them. This is what the technical process of extracting or identifying features. Identifying feature is a very difficult task, identifying good features.
I see. All right, Professor. And for the last question, Professor, because of limited time we have here, we have the questions from Mr. Dwi Budi Santoso. Which processing steps can be decisive in
improving the accuracy, and what factor determines the choice of pre-processing method? Yes. Okay. Yes, good question. This is pre-processing. First of all, we need to understand that what sort of artifacts we will be encountering. Usually in the case of a EEG signal that we are having, there will be muscle artifact, because the person is sleeping, he may change posture. So because of that, there will be artifacts, and we try to remove high frequency components because of the muscle activity. So we may use those filters which remove high frequencies. We may have something which is known as DC wandering in the signal, because when we use an amplifier, if it's not a very good amplifier, there will be a DC offset, a variable DC offset coming. So usually we use a high pass filter which is having a cutoff frequency from 5.5 hertz onwards. So it removes very low frequency from 0 to 0.5 hertz, and it will try to suppress the DC bias which is present in the signal. Then the third thing that we need to look into is that if I am doing a recording, I should know what is the supply frequency, the AC supply frequency is it 50 hertz or 60 hertz? If it is 50 or 60 hertz, I will use a notch filter to remove that interference. Apart from this, I have to take other precautions, like the person whom we are having the EEG recording, he should have actually a shampooed hair. He should not have oil in the air, so that the hair will have a problem in contact, and we will have a lot of noise coming from the contact itself. There should not be mobile phone or other instruments which are generating electric field that will interference. So these are the things, and people have used denoising techniques also, like Venner filter or wavelet based denoising, if it is contaminated by some external noise as well.
Okay. All right. Thank you very much, Professor. It was so delightful. We have a lot of questions and people so intense to ask. And before we leave, Professor, we actually have to give a certificate from Steve Kubang University for Professor Umar Farooq, who already attended and gave us a lot of insightful information in this conference. So please give applause for Professor Umar Farooq.
Thank you. Thank you very much.
All right, once again, thank you again for being here with us, Professor. We will see you again next time.
Thank you very much.
Thank you very much. All right, ladies and gentlemen, coming up, we have the second session, and this will be happening after the break. Welcome back to the second session. We've already have Professor Andy Liu from Help University, Malaysia, and we're very excited to hear the perspective from Professor Andy Liu about an overview of smart technology and creative economy and national development among some Asian countries. And this is a brief intro for our second speaker. Professor Andy Liu has graduated PhD from University Sains Malaysia in biotechnology. And his fields of interest and visualizations are the quality assurance in higher education, tertiary education conventionals, change management, strategic planning of the university, and also Prof. Andy is a pro-vice chancellor for Help University. And many experience came from Professor Andy, especially in open distance learning. Well, ladies and gentlemen, let's give a round of applause to welcome our second speaker, Professor Andy Liu. Professor, the screen is yours. Good morning, Professor Andiliu. Can you hear us? Good morning, Professor. Is my voice clear in your laptop or something? Excuse me, Professor, we cannot hear your voice clearly in this Zoom meeting.
Hello.
Yes, Professor, now we definitely can hear your voice clearly. Thank you.
Hello.
Yes, Professor? Professor Andy, well, I think we already heard you enough in here. Is my voice clearly inside there? Okay,
Hello.
yeah, hello, Professor Andy. We still have a little bit trouble in here with the image and also the sounds from Professor Dr. Andy Liu. Okay, so we will have to wait from Professor Dr. Andy Liu for a minute.
Hello, Aka. Can you get the
Yes.
CIC team? Okay. Hello.
Yes, Professor, we can hear your voice, but we still no image with the screen with you.
Oh, is my voice clear? You?
Yes, now your voice is clear, but still no pictures in your screen here.
Okay, just a second.
All right. We will wait. It's okay, Professor.
I'm so sorry. These are some of the technical glitches.
That's okay. Now we can see you clearly.
All right. All right.
All right. Okay. Welcome, Professor. We're so excited.
I'm so
to
sorry.
hear
I missed out
insight.
whatever that you were trying to mention just now. Ibu, so sorry.
All right. It's okay, Professor. Well, Professor, I think the time is yours.
All right. Just like let me call up my slides.
All right.
Ibu, is my slide visible?
Your slide is very clear visible here.
All right. All right.
All right.
Okay. Thank you so much, colleagues from Indonesia. Salam pagi, ibu-ibu, bapak-bapak, and as well as if we have participants from other countries. When I came in just now, I heard about the sleep apnea. My immediate response was, did I enter the right forum or seminar? Because the topic I'm presenting today is actually on smart technology and creative economy, because I thought I was in a wrong medical related seminar. And I quickly texted Ibu Ati to ask whether am I in the right forum. So I am indeed, because from what I understand, this is an international conference on multidisciplinary studies. And perhaps that is why I'm hearing things from Professor Omar just now on the sleep apnea. And we all understand there is always this challenge, there's always this cabaran kekangan when we have seminar conferences virtually, secara maya. And it is, of course, our intention is to be with you in person, but unfortunately, because of limited time that we have, and also the original speaker was supposed to be our chancellor, but unfortunately, he has prior engagement, and he's now actually in a plane to Thailand. All right, so he asked me to convey his apologies to all of you. He asked me to convey his apologies to all of you for not being able to be present virtually to be with you. So I would try to go through this as in my capacity as the director of the Health University, sharing with you the smart technology and creative economy dari segi creative economy transformation to support post-pandemic development. Now, most of the time, it will be a challenging journey, especially when we are the last speaker for the session, as the memory bank of the audience would probably reach the saturation point. So nevertheless, I hope all of you, that there are 400 plus when I came into the Zoom just now, that you would reserve some memory space for me to share with you on this smart technology and creative economy. All right. In Malaysia, we have this culture of reciting a pantun before we begin. So, bulat air kerana pembentung, bulat kata kerana muafakat. So, terima kasih yang tidak terhingga dari pihak kami di Health University kepada penganjur second ICMS for organizing this event. All right. Thank you so much to all of you. You would all agree with me that no forces in this universe can possibly stop time. Never. None of us can do that. So when time passes, no one can reverse it. So on that particular note, I was told I'm given about an hour to share with you on this thing called smart technology and creative economy transformation to support post-pandemic development. Bagi pihak saya akan usahakan to make sure this will be available experience for you, especially you are spending your valuable time with me. So I hope you will return with the required info, though it may not be a detailed one, but it will be sufficient to pave your way to more information.
All right. Professor, excuse me, there's a bit of questions here. Can you make the slides as full slideshows because it appear little in our screen?
Oh, appear small, is it?
Small, yeah, right.
All right, let me see. Is it bigger now?
Not yet. No, yeah, it's better now.
Is it better now?
Yes. Thank you, Professor.
Oh, thank you so much. Mujur, you provide this feedback to me. Otherwise, I'll be testing the eyesight of the participants with the small fonts and projecting.
Okay, thank you, Professor.
All right, you're welcome, Iwajin. All right, now all of us in this platform, or practically everyone, we all have a story to relate. All right, we all have stories to tell. We all have stories to tell. to share. So my story today with all of you here basically covers 4 broad aspects. The overview, and also sharing with you some of the success stories related to creative economy. And the stories that I'm going to share with you will focus more on the Asian countries, And of course, we need to look at what are the government policies that will help us to drive to achieve a more robust creative economy. And finally, the conclusion from the entire sharing session. So perhaps the usual question that people would ask, or some of you may be wondering, what is this Pak Andy Liu trying to share with us today? Especially this word economy and creative. How do these 2 words actually link together? Now, creative economy is very, very different from the traditional industries that rely on tangible goods and services, because the creative economy actually revolves around the intangible assets, intangible as what all of us would perceive. When we say something which is intangible, it is actually related to ideas, related to creative expressions, related to intellectual property. So when we talk about creative economy, it is the economy activities. It is activity economy that are based on creativity, that is based on knowledge and cultural expression. And when we say creativity, knowledge, and cultural expression, of course, the immediate question that will come to us would be, what does it encompass? What kind of sectors would have this creativity, knowledge, and cultural expression? Of course, it is none other than the arts and culture, design, media, entertainment, architecture, advertising, fashion, film, music, software, and gaming, and a lot more. The list will go on and on. All right. Perhaps the first thing to help you to connect to creative economy is look at K-pop. Look at K-pop industry. Look at the cosmetic industry from Korea. Every time bila kita pergi ke Korea, the first thing kita nak, let's go to this shop to get the face mask yang amat-amat murah ataupun pelbagai range yang dijual kat sana. So this is one of the examples. Or when there is a K-pop group coming to Malaysia, the youngsters, or going to Indonesia or anywhere around the world, youngsters would be very, very impressed. Like, I must go to this K-pop. This is actually my idol. Idola saya yang saya respect, yang saya follow through the FB dan pelbagai social media platform. So these are basically what creative economy is all about. So with that mindset, when we understand what is creative economy, then we will look at how does the smart technology that we have, with the advent of technology, bagaimana dia akan drive the creative economy. So this is where the following slides would show you the role of this smart technology in creative economy transformation. And as you can see in the slide that I'm sharing here, there are 3 major drivers. One is the enabling collaboration and breaking geographical barriers. And how do we democratize this? And how do we transform this new media and digital art? So the first thing when we look at enabling collaboration and breaking geographic barriers, we must remember that smart technology, I'm referring to smart technology, would allow artists, pelakon, for example, penyanyi, and collaborate across geographical boundaries. So there is no more geographical boundaries. The other one would be how does cloud-based collaborations, tools, and workplaces facilitate this real-time collaboration. That means physical location will not be a limiting factor anymore. And thirdly, of course, the cross-border collaboration. The cross-border collaboration that fosters the exchange of ideas and leads to a more diverse range of creative inputs. For example, in Malaysia, we have, or rather in America, we have this talent show. In Indonesia, I do watch this Indonesia Best Talent, all right, with all the best talents all around the world showcasing in just an hour of that show. And this is what creative economy is all about, all right? So the next thing is, I would like to share with you some of the success stories of creative economy. And when we look at the successes of creative economy, you would probably need to understand how the traditional gatekeepers are challenged as creators, where they are impossible for them to reach global audiences directly. Look at platforms like Amazon, Spotify. They are here providing opportunities for creators to thrive and bypass traditional barriers. And we also have this thing, I'm not sure whether you have heard about this thing called non-fungible tokens, NFTs, that have revolutionized the art world. And this is enabling people to get involved in direct sales from digital artists to collectors. For example, if I'm an art collector or on certain antique stuff, I can actually use this NFT to purchase the particular digital artist sales from the virtual world. And of course, the other part that is revolving around creative economy is definitely the AI, artificial intelligence and machine learning. These two very important tools have actually generated artworks that push the boundaries of creativity and traditional notions of art. Recently, I'm not sure whether you have heard of the news whereby the fashion designer actually uses one fashion designer actually uses AI to create the dress for a particular pop star. And this one is actually created by AI, not by a human being. So can you imagine this is how AI and machine learning is playing a very critical role in driving creative economy. So when we look at success stories, let me bring you some of the success stories in Asia. For example, South Korea, China, India, Singapore, and a few others. So let me start off with this South Korea, okay? And we all know South Korea is a global powerhouse in the creative economy, leveraging smart technology for growth. Now, the strategic use of smart technology has driven the success of industries like K-pop, K-drama, and I know I'm not sure whether in Indonesia, K-drama is one of the top shows in Indonesia, but certainly in Malaysia. In Malaysia, people will spend hours and hours just to finish that particular drama episode, whether it is 10 series or 1 series, they will just spend so much time, all right? Sampai ada yang menangis just menonton this K-drama, all right? And this is where you see South Korea is so smart. They are using this strategic use of smart technology to drive the success of K-pop, K-drama, and K-beauty industries. K-beauty industries. And of course, the other thing that South Korea is doing is they are actually using a lot of social media, digital streaming, and virtual interactions that help these artists engage with global audiences, transcending language and cultural barriers. Now, South Korea, digital innovation has created so numerous opportunities for content creators in the global market. Now, let's move on to another country now. Look at Singapore. Look at Singapore itself. Singapore has positioned itself as the hub for design and technology, where it has fostered a vibrant creative economy. Now, I'm not sure again whether you have heard of this initiatives launched by Singapore called Design Singapore or Smart Nation. These two initiatives has actually driven innovation and growth in Singapore's creative sector. Now, the other part that Singapore has done is on smart urban solutions that has led to innovative projects in architecture, urban design, enhancing Singapore's creative economy. Now, if you have been to Singapore Airport, which is the Changi Airport, you have seen the massive development that has occurred. Look at the architecture, and some of it is actually leveraging the creative economy. Now, the integration of design and technology has definitely propelled Singapore's animation, gaming, and media industries. So this is to show you from the two examples of the success stories from Korea and China. You will see that creative economy plays a very, very critical role in their economy. Now, the next one, obviously, is this China. Now, China's economy thrives on its digital infrastructure. And of course, again, you have heard of these two very huge tech giants like Tencent and Alibaba. You just Google, while you're listening to me, you just Google what is Tencent in China. You will see that China has this platform called Tencent. So Cent. It basically is about 10 cents. I guess this is how they get their name. It's a platform that transforms entertainment and media through social media, gaming, and digital content distribution. And the other one that all of us would have heard of it at any point of time in our life, is Alibaba. Alibaba's e-commerce platform has revolutionized retail and contributed to the growth of the creative economy. And these tech giants, there are two examples only. There are many, many more in China. They have opened new opportunities for content creators, entrepreneurs, and innovators in China. Now, the next success story, I'll bring you to this country known as Hong Kong. All right. Now, Hong Kong creative economy is nurtured through vibrant creative industries and smart technology. And I would draw your attention to the number 2. So you see number 2 is what they call the Television Broadcast Limited. And all around the world, we are all drawn into this TVB drama. And some of the TV dramas nowadays are fantastic, all right, where they deliver content and engages the audience through digital platforms. The other one is Pacific Century Cyberworks. This is an entity that enhances creative and digital economies in communications and media. Now, the next country I'm going to bring you to will be India. All right. Now, India's startup ecosystem fosters innovation in sectors like e-commerce, digital media, and technology-driven design. And I am very, very sure Indonesia, your younger generation, or perhaps the middle-aged generation, they love Bollywood movies. All right. So this Bollywood movie, which is in India's film industry, has contributed significantly to the creative economy. And the other thing related to creative economy is the IT services companies, like Tata Consultancy Services, that support digital transformation in creative industries. And India's creative economy has experienced tremendous significant growth driven by digital transformation. And this is where I think not only higher education has felt the impact of digital transformation, but across all industries, where transformation is now driven by digitalization and digital transformation. All right. So these success stories that I shared with you on South Korea, Singapore, China, Hong Kong, India, each of these countries actually leverage on smart technology to drive, number one, growth, innovation, and international recognition. So whether it is a developed country or country which is rising to the level of being a developed country, we must leverage smart technology, because it is through smart technology we will see growth, we will see innovation, we will see international recognition. All right. Now, the next one, the next sharing session with you would be on the government support. The government support is very, very important to drive creative economy, because without this support from the top level, the creative economy would not bloom as much as we desire it to be. And probably while I'm showing this slide to you, there will be some of you out there will be thinking, why ND is telling us this government support? What is ND trying to bring us into? What is ND looking at? So I can just basically off the cuff and tell you, when I mention government support, it is more on policy formulation and regulation, right? What are the policies that government should formulate? What are the policies that will regulate creative economy? How would the government support this creative economy? Is government going to provide us grant, loans, tax incentives? And what would be the infrastructure development? What kind of infrastructure is required for creative economy? Then, of course, the next part will come to us as the education provider. How would the higher education or education and training division be involved in this creative economy? And definitely the other aspect would be R&D, research and development, because we have to look at how government can invest in R&D activities. So basically, when I project this particular slide to you right now, is to tell you the importance of government support in driving creative economy. So let me go through with you one by one, very simple one. Now, as you can see in this particular slide, it is focusing on formulation of policies and how it is regulated. And this is very, very crucial in creating what I call a conducive environment for the growth of this creative economy. And the policies that the government would be looking at will have to protect the intellectual property rights. The policy must promote innovation. The policy must ensure fair competition among different providers out there. Now, other than that, the third point here would be, how would the government develop this policy and establish a regulatory framework And these framework, of course, must provide clarity and legal certainty for businesses or even individuals in the creative economy. The next one would be on the financial support. As I mentioned just now, what kind of support can the government provide? It can be support by providing grants, loans, tax incentive that will stimulate the growth of the creative economy. Now, of course, the startups and small businesses will benefit from this financial assistance to overcome the barriers or financial challenges and foster innovation. Now, the other point that the government will be looking at when it comes to support from the government would be the infrastructure development. The government would need to invest in robust and reliable infrastructure, robust and reliable. And the government needs to allocate resources. For example, if you were to go to this place, a particular government building or in this particular industry, we will say, oh, how is your internet access speed? So this is where everyone would expect to develop a high speed internet access. And the other one, people will say, oh, I am now storing all my information virtually. So what we need to look at is, are there data centers that will help me to store this? Are there backup centers? What is the aspect on the cybersecurity policy of the government? Okay, so this is another thing that all of us would have to really zoom into it and understand. The cybersecurity is coming up, all right, it's coming up, and data privacy and protection is also equally important in this aspect. And these infrastructure that has that the government will be investing will provide necessary tools and platforms for creators to thrive, right? And of course, we are all in the education industry. So when we are all in the education industry, we would have to remind ourselves, if you have a program of study, if you have a training course, how do I integrate these skills into my education curriculum? How do I provide these training programs to steer the creative economy? What kind of skills that they're required for upskilling or reskilling in driving creative economy? So in short, at the end of the day, we must ensure a steady supply of talent. The talent is important because without the talent, you cannot drive this creative industry. And to build up this talent, you must equip these individuals with necessary skills for success in the creative economy. You must equip them with the necessary skills. They may not have it when they pursue their undergraduate degree or diploma program, but they are now in the particular industry where creative economy is thriving. They need these specific skills, all right? And of course, the other aspect, as I mentioned just now earlier on, would be the R&D. The government understands or acknowledges the importance of R&D because R&D activities will spur innovation. If there is no R&D, there is no innovation, it will become stagnated. Okay, tak ada kemajuan langsung. And for the support of R&D initiatives in creative industries, we must look at how it will facilitate the development of new technologies, new products, and services. Okay. Now, the second but last support from the government is on the international trades. International trade. If you are doing this international trade, does the government promote the creative economy internationally through a trade agreement? Do they have that? Does the government support the export of creative goods and services And does the government attract foreign investors into the creative sector? These are all the questions that we need to look at when we are saying there must be government support in the international trade arena. Now, the next one would be the partnerships. This partnership is important because the government cannot function in silos. They must partner with organizations, businesses, academia, civil society, and international organizations. That means there must be a collaboration effort that enhances the growth of creative economy. And this is why when we look at collaboration and coordination among stakeholders, this again will lead to innovative solutions, knowledge sharing, and a supportive ecosystem. So at the end of the day, the support from the government to me is important, is crucial because it is creating an enabling environment for its growth. So this is where we talk about policies, financial assistance, infrastructure development, education, R&D, international trade promotion, and partnerships. These are key areas that will make a positive impact in the creative economy. So lastly, the conclusion here would be smart technology driving creative economy. We need to look at these three very important takeaway message. Number one, how do we foster a supportive ecosystem? Number two, we must understand the creative economy is not an entity which is by itself. The complexity of this is massive, meaning it is multifaceted nature. And to drive this creative economy, we must look at strategies, we must devise strategies, and we must have focused efforts because we understand creative economy in various industries have their own challenges. And for that, we need to see how to overcome those challenges to reap the benefit of this creative economy. So with that, thank you very much for being with me for the past half an hour or so.
Well, thank you, Prof. Andiliu. We're so excited to hear from you. A lot of insightful information, and related to that, we actually have a question in here because we're talking at the first. We have Korean that really grow very well with the economic creativity, and the questions from Ms. Satika is it possible to implement the transformation of creative economy from Korea to another country? So maybe is that good to implement the same creative economy to other countries following that South Korea? Professor.
Thank you so much. I have to shift off my camera because my line is a bit unstable.
All right. Okay.
All right. So on the question here, if we want to mirror the success of this South Korea creative economy, we'll probably need to look at what would be the cultural phenomenon in Indonesia, for example. Are you looking at Indonesian wave as Korea would have what they call the Korean wave? And also, when you look at the success stories in Korea, I believe Indonesia is actually doing it right now, where the artists and entertainment companies in Indonesia, you have actually harnessed the power of social media platform. I have seen a lot of artists using digital streaming services. I've seen also people interact virtually with these artists. And this artist has able to reach and engage not only with audiences in Indonesia, but globally. So to me, it is possible, and for you or any countries to adopt this South Korea's creative economy, you've got to look at digital innovation, number one. Number two, you got to look at how do you create opportunities for these artists, musicians, and content creators to flourish in the global market. So that would be my take on the question provided there.
Okay, thank you, Professor. Well, actually, in Indonesia, there's a lot of celebgram, if we can say, because of the rise of digital social media. So it's kind of more like Korean, South Korean with the creative economy, but also we also have a big audience. Indonesia have like 230 million people. So,
Wow, okay.
yeah, right. So it's kind of when you are in a digital creative like this, it's so many people will follow you in social media. So that's why it's going to be rises. But how about in Malaysians as well? Is there maybe common obstacle that this transformation creative economy in Malaysia?
Yes. You're also thriving in the creative economy industry. As what I've outlined just now, remember, Ibu, that we have to thrive on digital innovation. We have to look at how to create opportunities for these artists and musicians and content creators. And this is exactly what Malaysia is doing on the creative economy, especially when you're talking about the entertainment industry.
Okay, Professor. Well, actually, I just want to ask to the audience, maybe have a questions for Professor Andy Liu before we leave the first session and second session, sorry.
Yeah, I think before that, Ibu Ajen,
Yes.
the other thing that, because we seem to be focused on entertainment, right? When we talk
Right.
about creative economy just now, from the way the questions are being posted.
Yeah.
In Malaysia or generally around the globe, the creative economy actually refers to any economy sector. Remember, right from the beginning, I mentioned any economy activities or that encompasses things like creativity, culture, and arts. And this one varies from industry to industry. Like, for example, you have film and television, you have music, you have performing arts, you have visual arts, you even have fashion, right? As I mentioned, there is one particular person that uses AI to create this dress for this superstar. And of course, the other aspect of creative economy in Malaysia, for example, we also look at publishing, digital media. And the government has also recognized the potential of this creative economy. And this is where they are paying special focus, emphasis on this, because to them, this will drive economic growth. This will promote cultural diversity. This is important because when you promote cultural diversity, in other words, you are making sure there is harmony between various races, right? Right. And also this will also be able to generate employment. So whether it is in Malaysia or whether it is in Indonesia, everything that relates to creative economy basically would revolve around creativity, culture, and the arts.
I see, Professor. Well, this is we have a last questions, Professor, before we leave the sessions. The questions coming from Miss Lisa Desianini. Who has the biggest opportunity in creative economy based on education? Do people have the same opportunity, or people who have higher education has more opportunity than people only in high school?
Okay, this is a very challenging question because when you're saying who has the biggest pie, in other words, right, when it comes to creative economy. Now, I think if you want to determine which stakeholders will have the bigger opportunities in the creative economy, it is actually very subjective and dependent on various factors. Very subjective and dependent on various factors. Different industries will have their own strength, resources, and unique cultural landscapes. So my advice, I can't really narrow down on which, but I would say to determine which particular industry will benefit more, it is all dependent on the strength, the resources, and the unique cultural landscapes. All right, perhaps when we go to Indonesia, it will be the education sector. When you go to Korea, it will be the film industry. When you go to Hong Kong, it will be the media industry, right? So it is very difficult to answer that particular question, because at the end of the day, we must look at the strength, the resources, and the unique cultural landscape.
Yeah, most of the human resources are kind of different with different countries, yeah, Professor.
True. And even within the country itself, the subsector of the industry also would have a variable resources in terms of strength and the cultural landscapes.
Okay. See, so now we get the answers, Miss Lisa.
Right, I hope.
I have a different one.
Yeah.
Okay.
So-
Okay, Professor, because it's due the time, it's already 11 and there must be already 12 in Malaysia, right? So
Yes, I have
before
a
we,
meeting to attend.
yes, that's why before we end this session, we actually have a certificate for you who already gave an insightful knowledge. So please, everyone in here, give applause for Prof. Andy Liu.
I heard the applause for Professor Omar just now.
Okay, thank you so much. Yes, thank you so much.
Macam masuk the Grammy Awards punya hall.
Yeah, it feels like in the Grammy. That's the Creative
Ibu,
Academy
perhaps
one.
I would end with a serangkap pantun for all of you.
Sure,
Nice.
Professor, please. We're going to hear the pantun.
Kalau dapat ku peluk awan, bulan akan ku usung ke riba. Sehingga
Oh,
sini para budiman bertemu lagi bila takdir bergema.
okay. Thank you so much. Cakep. We can say cakep in Indonesia. If someone read a pantun, we will say cakep. Something like
Cakap, okay.
Okay. Okay, thank you so much, Professor Andy Liu, for a great
Thank you.
presentation.
Most
We will
welcome. Thank
see you
you.
again next time, Professor. Thank you.
Inshallah, ya. Bye.
Yeah.
Okay, ladies and gentlemen, let me take some highlights from overall discussions as we embark on the path of post-pandemic development. Let us remember that smart technology and the creative economy are not just as tools, but they are also enablers to make a better futures. By harnessing their power, we can build resilient societies, drive economic prosperity, and also create a world that is more connected and also innovative. So, ladies and gentlemen, please give applause for all the speakers in here and also for all of you that already attend this conference. Thank you for attending, and we hope that this is going to bring you a new insight for the future. I'm Ajeng Aquinia signing off from here, and over to you, Miss Atik and also Miss Amalia.
Okay, thank you, Miss Ajeng Aquinia. What a beautiful speeches with our speaker, Mr. Umar and Mr. Andy. Thank you very
Yeah.
much for the wonderful speeches. Yes, Miss Ali. And hopefully, it's very, very inspiring innovation. Hopefully, we can apply it in our lives to take a benefit from smart technology and inspiring creative economic transformation, especially in post-pandemic life. Well, ladies and gentlemen, please pay attention for a minute to all of parallel station presenter. You can see the list of the presenter that we will share in screen for parallel station. Then we will have a break for an hour, and you should to come back at 12:30 at WIB Indonesian time to the main room and wait for the host to assign you the specific breakout room.
Okay, we will break for a moment and we'll come back again. In breakout room, you all will be moderated by Alicia official. See you later.